Hello again. In this video, we're going to find derivatives involving the arcsine function. Okay, so theorem 319 tells us that the derivative of arcsine of x is 1 over the square root of 1 minus x squared for x values trapped between -1 and 1. Okay, so let's find the derivative of arcsine of x squared minus 1. Now, in order to find this derivative, we're going to have to use the chain rule because this is a composition of two functions. And of course, this is the chain rule. dy dx is equal to dy du times du dx. And so let's let u be the inner function, which is just x squared minus 1. And that means our outer function is going to be arcsine of u. Okay, so dy du, let's find dy du. dy du, we can find using theorem 319, which says that the derivative of arcsine of x is 1 over the square root of 1 minus x squared. But instead of x, we have the variable u. So the derivative of arcsine of u with respect to u will be the u instead of an x. So it's 1 over the square root of 1 minus u squared. Then we can replace the u since it's equal to x squared minus 1. Okay, and let's go ahead and FOIL out this x squared minus 1 squared. Okay, so you get x to the fourth minus an x squared, and you get another minus x squared, so that's minus 2x squared, and then plus 1. Okay, so that's going to be our outer derivative. Okay, and then our inner derivative is going to be du dx, which of course is just 2x. Okay, so by the chain rule, we have our outer derivative times our inner derivative. And then let's just go ahead and simplify this. This will be 2x over, and then let's distribute this minus sign. So over the square root of 1 minus x to the fourth plus 2x squared minus 1. Because these change signs, right, when you distribute the negative to each of them. But then the 1's cancel out. So we're left with negative x to the fourth plus 2x squared underneath this square root. And it might be better to write the 2x squared first. It just looks a little nicer. And so that's the derivative of this arcsine of x squared minus 1. Okay, so we've done things like this before where we've had to use the chain rule. So this is really a chain rule problem. But we also had to use this theorem 319 to find the derivative of arcsine of u. Okay, so let's look at another one. So here we want to find the derivative of cosine of arcsine of x with respect to x. Now again, this is a composition of two functions, so we're going to need to use the chain rule. Then u is going to be the inner function, which is the arcsine of x. And that means our outer function is going to be cosine of u. Okay, so then let's find dy du. So the derivative of cosine of u with respect to u is minus sine of u. And then let's replace the u. So we get minus sine of arcsine of x. These are inverse functions of each other, so if you take sine of its inverse sine of x, that just leaves you with x. Remember, when you take f and you compose it with its inverse function, cancel out and you're just left with x here. And so here we're just left with minus x. Okay, so that's our outer derivative. And then we need the inner derivative, du dx, which is simply the derivative of this arcsine of x. And again, by theorem 319, that's just 1 over that square root of 1 minus x squared. Okay, now we just have to take the outer derivative times the inner derivative. And of course, you can write it like this. And so that's the derivative of this cosine of arcsine of x. Okay, so I hope you found this video helpful. Thank you for watching.